Okay, we're going to start. I'm Elizabeth Ann Kaplan. I direct the Humanities Institute here, and I'm delighted to welcome you to the second Institute event this semester, and the first in what I hope will be an ongoing collaboration with the Simons Center. Really delighted to work with Fred Goldhaber setting this all up. It's been an exciting process, actually, but we are all here being very delighted to co-sponsor this event with the Simons Center. I'm just going to announce two upcoming Institute events, if you'll bear with me. Tomorrow at 3 o'clock, actually, in the room across the way where we were, Nicholas Fisher will talk on Fukushima radioactivity and risks to humans and marine life. On Tuesday, September 24th at 4:30, also across the way, Peter Caravetto will present his book with discussion by Bob Crease and Nana Golden, his book, The Elusive Hermes. And we have a conference, a one afternoon event at the Manhattan campus, which continues our memory studies project. This time our event is called Memory, Culture, Media, Cognition. That will be Friday, October 11th, 2013 in the Stony Brook, Manhattan campus, and you're all welcome. More pertinent to today, tomorrow, what is wonderful that Alice Major will hold a workshop. That will be over in the Simons Center. We think room 103 it's announced as here, but it's possible, given numbers, it may move, but there will be signs as you enter the Simons Center, if that's the case. The flyer asks you to register, which you can do very easily by going online, but I'm sure nobody's going to be turned away from the door if they're not signed up. So with that introduction here, I will turn you over. Yes? Yes, tomorrow at 3 o'clock. Yes, 3 o'clock in the room across the way. Okay, there are flyers. By the way, there are flyers for everything that I've mentioned, plus the Institute's busy calendar at the back of the room. So do pick those up as you leave. I'm going to hold you over now to Fred Goldhaber. I think he's well known to you as a member of the Physics and Astronomy department here and a specialist in nuclear and theoretical physics. So, Fred, thank you so much.
Thank you. The trouble with introducing speakers is that the more wonderful the speaker, the more there is to say in introduction, and the less time is left for the speaker to speak. I feel we have quite a wonderful speaker today. I met her, together with my wife, I met her last summer at the conference called Bridges Between Art and Mathematics. And I wasn't even able to hear her talk then because we arrived too late for it. But we met at a couple of meals, and then we kept wanting to talk more. And so I soon became aware that here we had a very unusual person. And then I was able to read her book called Intersecting Sets, A Poet Looks at Science. And this is technically not a poetry book because it is mostly in prose, but the prose is of such a lovely quality that I think one could consider the whole book one long poem. And to help you see why it's worth having come here today, let me explain one of the things that happened in trying to arrange for this visit. I was showing an important person who had to think about whether we wanted to invite Alice, and I lent him her book. And you know how it is when somebody lends you a book. You put it down somewhere, and then maybe eventually you read it, or maybe you don't. And then the next thing that happened was I asked for the book back. And I got the following message: I'll give you back the book tomorrow. The next day came, tomorrow came, and there was a new message saying, I can't give it back. I have to finish the book. And therefore, I'm going to stop now so that Alice has as much time as possible to finish the lecture. need to hook this.
Hook me up. Too much technology for a poet. This is, can you hear me?
I'm afraid you need to hold the other.
No, I don't. I'm hooked in. I have got 2 microphones attached to me. I feel like a gunslinger. Thank you so much for your introduction, Fred, and I am truly delighted to be here. It's an honor and a privilege. So I would like to thank Fred for making the initial to the Provost for making this part of the lecture series. Certainly want to thank Dr. Kaplan and her lovely staff at the Humanities Center who've helped with the logistics of this intersection of sets. Could I just get a little bit of acquaintanceship with you? How many are in the sciences? Okay. How many are in the arts? Okay. Are there any poets? 1. Oh, good. All right. I decided to call this lecture a superposition of brains. But I have to say that the word lecture has such an authoritative tone that I thought I'd ease into it a bit. I am going to read you a poem. And it's one with a direct connection to the lecture title. And there's a little story behind it. I'd been named the poet laureate for my home city of Edmonton. And there's about 1 million of us up there where the boreal forest just about begins. And one of the things I had to do as poet laureate was write poems for special occasions. This does not usually lead to great poetry. And one of my first assignments was going to be to write a poem for the Mayor's Evening for the Arts. Now, I had a complication. We were in the middle of huge civic excitement because of the NHL hockey playoffs. As a matter of fact, our team was within lunging distance of the Stanley Cup that year. And I knew that everybody in the audience really wanted to be home watching this particular game, which was almost at the end. The mayor kept announcing the score between the arts awards. So I felt I had to address hockey in my poem. However, I may be from Canada, but I know nothing from hockey. So I had to go around in my brain hunting for some way to make this engaging. And I came up with the idea of superposition of states. You know that concept, and the scientists will understand, where a subatomic particle like an electron exists in all its probable states at once, and you never know which one until you measure it. I figured I knew just about as much about that as I did about hockey. So this is the poem I came up with. And it is called, I Never Thought I'd Write a Hockey Poem. Climbing dim stairs at midnight when spring has struggled back like the shifting fortunes of a playoff series, and the May tree is shaking out its tasseled blossoms, while the full moon skims down the sky, a white puck. A mile or 2 away on the frozen cloud surface of the real arena, a winter sport is superimposed on spring. Third period of overtime, and young men battle back and forth, trying to collapse wave on wave of possibility to a point of dense rubber, observed at last in one net or another. But I am going off to bed, leaving fortune in a superposition of states, not realizing I'll awake to a radio announcer's words, "We won," and find that gladness scores an absurd and unexpected slapshot. It's not specific consequences of a victory that really matter, not the celebrating crowds that surge from bars, a muddled wave machine of jubilee and mob, nor the poet who observes within herself a tremor of unfamiliar fandom and a poem. It's the mad fact that we live every moment of our lives in overtime, a condition of entangled futures waiting to be observed, Mayflowers and blue lines, uproar and moonlight, overlapping in the kind of world where anything might happen. Excuse me, and I hope this doesn't glug through the microphone. Now, you'll recognize I was using the superposition of states as a metaphor. And poets do this kind of thing all the time. And most of the time we tend to think this is a kind of decoration, something that's fancy and stuck on, not the same as the more useful daily forms of cogitation. But in fact, everyone in this room thinks metaphorically all the time, because that's how human brains work. So please hold that thought for a minute. I'll come back to it. But first, I'd like to make a disclaimer. I'm not an expert in science, whether cosmological or cognitive. I do know poetry pretty well, although even there's so much more I could know. And in everything else, I'm a magpie, a scavenger. However, I've been reading about science for 50 years and more. And I feel so much more rich for that experience, largely because it makes me feel that poets and scientists are doing much the same thing. We're trying to understand the world, and we're trying to communicate that understanding. So, with that caveat again, let me talk about brains. And I'll start with another story. Imagine a steeply raked lecture room in the engineering building at the University of Alberta, not unlike this. At the bottom of the tiers of seats, like a ball at the bottom of a pinball machine, is a celebrated Canadian poet-philosopher. Not me, by the way. She has come to talk about the relationship between poetry and science, and she speaks eloquently about the need to incorporate the emotion that drives lyric poetry, that intense attention to the natural world, into the rationality of technology. This emotion should inform the decisions that will affect the earth. And her talk is scholarly and passionate and inspiring. I mean, this is a woman who knows her Wittgenstein. I'm way out of my depth. I'm not going to argue points with her. And who'd want to argue that lyric observation and love of earth should not be taken into engineering choices? But I left the hall feeling vaguely argumentative. And I finally put my finger on it sometime later. Her thesis was built on that old assumption that art is emotional and science, along with its stepdaughters, technology and business, is not. But anyone who has ever worked in a lab or been through something as dull sounding as the regulation of the utility business, which I have, knows that all these human activities seethe with emotion. And whenever I sit with young friends who are early in their science careers, I feel that their enthusiasm is as exciting and contagious as any artist's. "Don't call me unemotional," says the scientist to the poet, looking around for something to hit her with. The human world is awash with emotion. Poets merely give that feeling a little structure. Now, this split between the rational science brain and the emotional artistic brain is probably the fundamental stereotype that haunts us to this day. After all, it's a way of thinking about thinking that's been around for at least a couple of thousand years. Now, of course, many, if not most of you, will know that it's a false dichotomy. For the past couple of decades, thinkers like Anthony Damasio have been vigorously pointing out that emotion is fundamental to logical thought. It's emotion that gives us that little kick of satisfaction that says, you've correctly figured out a pattern. You've recognized something. Whether that pattern is a new equation, a line of poetry, or a stock pick. And the upwelling of embodied cognition programs around the country is a welcome sign that the field of cognitive science is starting to flower into a much more nuanced understanding of the logic-emotion connection. But even if we know better, the stereotypes are still around, that science is cold and rational, while artists are flaky and all over the map. It's become what George Lakoff would call a frame, a narrative that we use to structure experience by mapping it onto some other area of experience. And it becomes so habitual that it's invisible. They become assumptions about how the world really works and how people really are. So, for instance, imagine your daughter has come home and she says she wants to be a biologist. What story are you going to project about her future? It's going to be useful, well rewarded, well respected. Her work's going to come up with something practical and tangible. She'll deal in symbol manipulation that you're totally unfamiliar with, but you won't understand what she writes, but that's okay. Other people who matter will. And she'll probably get a university post if she wants it. Now, imagine that your son has come home and announced that he wants to be a poet. This did happen to me just recently. Some acquaintances phoned me in a panic because their son had announced he wanted to become a poet. What story do you project about him? Impractical, romantic, out of touch with the world, not logical. His marriage is probably going to break up if he ever does marry. He's sure not going to get the university post. And you certainly won't understand whatever it is he writes. The only optimistic view of his future is that maybe he'll grow out of this. Now, Geoffrey Chaucer, 600 years ago, would have been quite astonished at this projected story about what a poet's character and prospects were. I mean, he didn't see any problem about being a poet and a very successful civil servant. And he was actually quite well recognized at the royal court as a poet. Wallace Stevens, who declined the university appointment, might be equally amused. So would Mary Oliver or Joy Harjo or any number of other poets who are successfully living their lives today. Now, if you were the parent, you'd say you were just being realistic about the job prospects for the kids. And it's true. There are not many poet-wanted ads out there. Heaven knows I have looked for them. But I'd argue that what we're reacting to is based as much on assumptions about the personality traits that you attribute to the different options. And these stereotypes, they don't just influence your conversations with your offspring about their future. They influence things like policy on arts funding, or the number of registrants in honors English programs, or how we teach different subjects, especially the sciences and maths. And they even affect literary theory and what poets think they should be doing. Poets can get very, very conflicted about science. On the one hand, we're calling it still reductive and deterministic. On the other hand, we're really envious of it. And sometimes we secretly adopt it. Only then sometimes we get stuck with outdated concepts because we haven't kept up. As just one example, I'd like you to think about those "the author is dead" statements that were made in the days of extreme postmodernism. Did anyone hear those? Not many writers subscribed to the idea that we were all dead, but the idea was that a text is created by its readers, not by the writer. That meaning originates in the language itself and not in the writer's intentions. And it became a powerful argument. Scholars got very excited by it, and poets actually started to incorporate it into the way they wrote. But I don't think we ever actually recognized that this is based on a particular view of the human brain. The behaviorist view of the brain as a kind of black box. Of course, back in the 60s, thinkers like B.F. Skinner were saying that really all you can know of the brain is what goes in, what comes out. What happens in the middle is invisible, inaccessible. You get certain stimuli resulting in certain outcomes, but what's in it between is aspic, and it could be shaped by any cultural stimulus that it encountered. Now, if you were a postmodernist literary theory, you'd be appalled to be linked in any way with behaviorism. That was a dreadful leftover of the scientific, the deterministic, the single narrative modernism that they were reacting against. However, in an unexamined way, that behaviorist picture of the brain is the basis of saying the author is dead. The black box is a metaphor. But if you take that metaphor to its conclusion, it follows there's no necessary commonality between how any two brains react to stimuli. And that means my experience of red can be entirely different from your experience of red. And this leads to that question that philosophers call qualia and debate with vigor through the ages. However, it's not hard to see that that picture could also underpin the view of theorists who imagine that literature is a kind of electric transmission grid in which texts get pumped in from various sources and energy is extracted by various users, but there's no necessarily A to B path for any given electron. Well, so you say, that's the humanities, we go off in all directions like that and get carried away. Scientists wouldn't do that. Is that the case? What's one of the most fundamental metaphors of science? It's essentially universe as machine. Each level of existence is made up of simpler bits, and we can explain the universe once we know how the most basic bits work. Now, in our ordinary lives, we're quite familiar with situations where parts are a whole lot more complex than what they add up to. For For instance, any highway engineer knows it's a whole lot easier to predict traffic flows en masse than the specific decisions of any idiotic individual driver. And that's a direct outcome of the fact that the number of neural connections in an individual's brain is far more immense than the numbers of drivers on an LA freeway. Cells are just as complex as the body they make up. The DNA within cells is as complex as the cells themselves. And as a matter of fact, if you get down to the nub of space-time, which we may, with Fred's help, get to some point, it's going to look just as confusing and manic, shall we say, as anything else. In fact, the universe isn't machine-like at all. You might say it's intensely fractal, like Cantor's nested infinities. It doesn't get less complicated as it gets smaller. It's more like the edges of the Mandelbrot set, infinitely complex at any level. But science does tend to still fall into that trap. We think there is going to be that one bullet. We often get funded because we present that. And I wouldn't want to imply that this huge initiative of science has been in any way less than revolutionary. All I'm saying is that science is just as prone to relying on its metaphors as any other human endeavor is. But enough of the metaphors. Let's go back to the poet's son and the biologist's daughter and ask ourselves, as they tackle their brains, as they tackle their lives, are their brains so different? What are they going to do with them? Let me take you to my grade 10 chemistry class. My bench partner and I are given a lump of blue crystal. We heat it with the Bunsen burner and it turns into a gray powder. We watch it as we add it back into water and it turns to a bright blue liquid. I stick the end of my pen in it and stir it, and then I stick my pen in my mouth. And then the teacher asks us for our observations. So everyone gives the same characteristics. I feel I really got to try something different. It tastes like copper pennies. The teacher leaps up in horror. "You don't mean you drank it," he says, and he rushes down as if he wants to get me to the nearest stomach pump. I barely have time to point out that the test tube is still full and all I did was get a little bit on my tongue. Relieved, he uses this as a teaching opportunity to point out that in future experiments we should depend on all of our senses for observing except that of taste. Now, in that experiment, we were being taught most of all to observe something for ourselves, to experience. And of course, that's related to the two words experiment, experience are related. That's a capacity that scientists and poets both have to train themselves in very carefully. And both kinds of brain want to find something that has not previously been captured in equations or words. We want to observe new things, not just the copper sulfate all over again. I was trying just a little too hard for originality in the chemistry class, but the impulse remains essential to all of us. And then once we observe, what do we do with that? Let's think again about that question of rationality. Is a scientist fundamentally more logical than a poet? I'd argue not. If you think so, I don't think you've ever written a poem. when you do, that first line lays down a kind of axiom that you are going to work through the whole trajectory of it, both logically and emotionally. Which, of course, is exactly what a mathematician or a scientist is trying to do with their observations. But more generally, at a very fundamental level, our brains don't work using rational logic first. Humans are often described as pattern-recognizing, pattern-making animals. But we perform those functions using probability analysis, not by learning rules. And I think this is what sort of tripped up Noam Chomsky all those years ago when he first posited a universal grammar for how children acquire language. Because he had this brilliant insight that we are somehow wired for language. But his idea at the time of the fundamental how of that was a bit off. It's not about deduction, about acquiring rules. It's about induction, our amazing ability for statistical analysis. When you think of it, it is truly amazing that a baby, a newborn infant, is starting to exercise that statistical analysis capability from the word go. I'm constantly awed by this. So that baby is learning language patterns through a constant back and forth among the sound combinations we hear. We use lemmas, rules of thumb, frequency of occurrence to analyze what we're hearing and structure it. And it's not a capacity that's just there about language, of course. It's something we use from the beginning for everything around us. In effect, the baby is saying, human face, I'll look at it. No, that combination of lines and blotches couldn't be a face. I'll ignore it. Our brains are constantly associating the input we're receiving, and it's recruiting and strengthening the neural connections so that they become automatic, accessible. But we certainly do use it big time in language. You might be surprised to know how accurately, as an English speaker, you recognize how probable it is that a sound like O will recur in a stretch of your language. The flow of sound goes over you, its ratios below your notice. But as a poet, I depend on that unconscious analysis. Your knowledge that O is the 8th most common vowel sound in English, to get your attention for a microsecond in a line of poetry. The flow of sound goes over you, its ratios below your notice. Turns out to be rather a nice Alexandrine line. Of course, we share our underlying, the statistical capacity with other animals. Whether we're mice or men, we group stimuli. We have this huge array of wavelengths coming at us across various modalities. And we parcel them into objects that belong together. And then we respond emotionally to the associated stimuli. We mark the combination and transfer it to our memory if it's significant. Of course, we don't really know yet how we do this. It's what cognitive scientists refer to as the binding problem, a phrase that has always given me a strange feeling. It sounds like a constipation ad, doesn't it? However, Humans take this kind of association to an entirely different level than the mouse does. More specifically for humans, it depends on our capacity to remember what we have observed in the past. An animal can certainly remember in the sense of recognizing a combination of stimuli that recur. Humans remember things that aren't right here, and we consciously compare them with other things. And we use the grouped stimuli from before as templates, highly flexible templates that we lay over new experience all the time. And we make leaps. In other words, we make metaphors. As I said at the beginning, we are all thinking metaphorically all the time. I sometimes think of this as our compulsive paperclip syndrome, the connection making that we're always doing. And it's founded on our capacity to observe, because the more you take in, the more you can connect. And for a long time, we've recognized that this capacity is at the heart of creativity. I won't belabor that point, because we're going to kind of play around with it tomorrow in the seminar, in the workshop. But and it's also something you find in just about every book about creative and how to be creative. Put things together that you didn't expect. But it applies to all forms of human creativity. And it's used all the time by poets and scientists. One of my favorite stories from mathematics is about the moonshine conjecture. Is anyone familiar with that phrase, the moonshine conjecture? Don't you love it? Don't you want to run out and write a poem about it? Well, John Mackay is an expert in group theory, which is the study of symmetry. And for a little light reading one night, he picked up this paper on a very different area, number theory, which is the branch of mathematics that deals with whole numbers. And in that paper, a particular large number popped up, 196,884. Now, that wouldn't mean much to you or me, but it was, to him, very close to a particular number that had been recently identified as important in his own field of symmetry. So he had no particular reason to think that two very, very widely different parts of math theory had any relationship, but he referred it to two other mathematicians, John Thomson and John Conway, and they went on to explore the coincidence, although it was Conway who came up with the moonshine conjecture. And he explained the name this way, quote, "The stuff we were getting was not supported by logical argument. It had the feeling of mysterious moonbeams lighting up dancing Irish leprechauns." But the connection did hold. The moonshine conjecture was subsequently confirmed, and it's extending its light into other parts of the mathematical forest. As a matter of fact, I understand it's part of string theory now. A connection that potentially brings a highly abstract mathematical idea back to the physical world. So, poets notice and create patterns in words and sounds, while scientists do the same things with equations and experimental data. Both use probability analysis, both depend on observation, and then we encode those patterns in highly sophisticated languages. Though surprisingly often that translation into language is a completely separate process from the original pattern recognition. Einstein's famous thought experiments are an example. He would talk about the process and say, "The words or the language in which they are written or spoken do not seem to play any role in my mechanism of thought." He would only get to the words later. And they sometimes don't even matter once words start to disintegrate. I just want to read you this little snippet about my father. Metaphor survives even when language itself is fragmenting. Look at the frogs, my father said. We were sitting in a tired coffee shop in a downtown office building while my mother finished a medical appointment upstairs. Dad, bundled in a puffy brown parka and wearing his dark green tartan bonnet, was staring out the window at the street. Startled, I turned around. Frogs on a concrete sidewalk in a prairie city at this time of year? Outside, I saw curled brown leaves were being whipped up by a wind around the building's sharp corner and skipping up and down. They didn't look anything like frogs except for that unusual motion. By now, language was a system in tatters for my father, who had been supremely quick and inventive with words. He could no longer articulate the stories he had hung on to fiercely for as long as he possibly could. All that was left were formulaic phrases. Pleased to meet you. Hello. I love you. Look at. He could no longer shuffle words into novel arrangements, but even so, he could observe and reach into the scrap bag of his mind and put emotion together with a memory. He said it slowly. Look at the frogs. The image was there in his mind, but he couldn't get it to language. When I looked at him, puzzled, he flapped his hand up and down, smiling, and gestured to the window behind me. Watching my father go through Alzheimer's was heartbreaking and yet strangely illuminating about how brains work. So, let's go back to the title, The Superposition of Brains. It's a huge topic, and I just want to refer to the double slit experiment. How many know about the double slit experiment? Okay, how nice. Love that one too. That's that setup, for those of you who are not familiar with it, that setup where you can either send light through a screen with one slit or with two slits, and the pattern behind it, on the screen, receptor screen behind, will depend on, will either look like a wave type of pattern, interference pattern, or a single particle type of pattern, if you have the right setup, the right experimental setup. And what registers depends on how the system is configured at the time. And to me, this is much like the human brain. Light is light. The world is the world with all its interacting possibilities. The patterns our brains make will depend on what we're configured to register. What shows up on the screen depends on what slits we're going to have open. The language of science, and it comes down then to the languages we use. The language of science obviously has to filter and focus information more. You do want to hit that defined bullseye. You might say that poets are a bit more of a two-slit experiment. Words interfere with themselves more in poetry. And we take advantage of that. It's fundamental to what we are doing. But we're not simply divided into single or double slits. As I mentioned at the beginning, I do call on logic to build a poem or to write anything. And any scientist is going to need to let the moon shine through the blinds. So to conclude, I would just like to read a little bit from the last chapter of my book. The title of the chapter, Brain Surgery, comes from an anecdote told about Margaret Atwood. It's probably apocryphal, but every writer wants this to be true. And the story goes, she's at this cocktail party, and a brain surgeon comes up and says to her that when he retires, he's going to write a book. And she looks at him and she says, "How nice. When I retire, I'm going to take up brain surgery." Writers love this story. Perhaps it warms our hearts because half the people we meet, from brain surgeons to cab drivers, tell us how they want to write a book, as if it was roughly equivalent to wanting to tour Spain this year. All they need is a little holiday time. Or perhaps we love it because we are secretly insecure. Is it really so hard to write a book? I write poetry because I find it easier than the options. It would be much harder for me to be a brain surgeon or a cab driver. One of my other favorite stories concerns William Hamilton, the great mathematician. Hamilton wanted very much to write poetry, and it took his friend William Wordsworth to point out tactfully that his talents did not lie in that direction. Quote, "You send me showers of verses which I receive with much pleasure, yet we have fears that this employment may seduce you from the path of science." Hamilton was a phenomenally creative and inventive thinker, and part of me thinks anyone who could handle the symbolic language of equations so jauntily could surely crank out an equally good poem. That he found it difficult is a relief. It seems to confirm I'm doing something that does indeed require something special. Yet, I would also argue with the people who tell me, "Oh, you were born that way," as if I had won some odd lottery. No one says that to the brain surgeon. When all is said and wondered, however, I know that what I do is different from what the brain surgeon does, and, pace Margaret Atwood, it's easier. Poetry does not depend on the huge edifice of innovation and knowledge that the scientist's vocation does. What I do could have been done just as well around the campfire of the Omo people 200,000 years ago. And it could be done well by many, many people today. In any class where I give a poetry workshop, there will be at least one student with a gift, that slightly tweaked sensitivity to language that could be the foundation of poetic ability. That brain surgeon just might retire and write a good book. This does not reduce the value of the ability to write. We do not value what comes easily to human beings because we do not realize how enormously complex it is to move, to recognize a pattern, to tell a story, to love. In the last century, we felt we had made poetry better by making it harder. The greatest gift of science in our time may be to help us understand how wonderfully sophisticated our simple abilities are, how long it took to evolve them, how they fit into the natural world as part of a continuum. As scientists continue their investigations, we will come to understand in greater and greater detail how the brain does its easy things. But science is also increasingly aware of its limitations, that the sheer volume of information required to understand even a single experience exceeds the descriptive capacities of laws and equations. Ultimately, the poet's description is as complete as the scientist's. From the brain inside the skull, looking out, I make observations of my world. I move words into arbitrary combinations, testing them for sound, testing them for a connection to my observations. I let their connections echo through the net of memory I've spun over decades of learning. I measure and fit, listening all the while to these new artifacts from old worlds, hunting through the combinations of the familiar for the ones that have not been made before. Thank you very, very much.